Alright, in this video I'm going to show you how to set up a multiplex between two 7-segment displays. So I've got the tens digit and the ones digit. So currently this is running. It's kind of hard to see in my basement studio, but anyways, we can't really see what's happening in real time, but essentially what multiplexing does is it turns on one 7-segment display and then very quickly turns it off and then turns the second one on, and then just repeats the cycle over and over again, numerous times a second. Okay, so right now, in my code, I've got a delay of 10 milliseconds between the multiplexing cycle. So it's bouncing from one to the next every 10 milliseconds. Okay, if I change that to a higher value, like let's say 100, and then upload that, and hopefully my upload works. Oh, it's not going to because I haven't unplugged it. It's going to work. See, it's not just school computers, it's my computer too. Nope, didn't work. Alright, so I'm going to unplug these. So that's the reason I use those jumpers. And then try it again. Oh, a bunch of errors. Okay, try once more. There we go. Third time's the charm. Okay, and reconnect my anodes very carefully. So you can already see it's kind of flashing back and forth. If I put my professional focuser on here, you can see it's kind of flipping back and forth very quickly still, but now we can actually see what's happening in the background. Okay, so multiplexing is used through a lot of electronics to save in wiring, and also just the general circuit size. Okay, so here, in this case, this is a pretty simplistic version, but you can see instead of having to, create a bigger Arduino, provide more outputs from our our microprocessor, we were able to use the outputs that we already have. We didn't need any more resistors. All we had to do was jump wires from our ones cathodes to our tens cathodes. The exact same positioning. So here, this bottom right pin goes to the same bottom right pin on the second one. And then all we're doing is just switching the anode, so the positive side, very quickly, and then turning on one and turning one off simultaneously. Okay, so I'll speed that back up so it's not flickering like crazy, and re-upload this. Plug those, or I forget, and plug these back in. Okay, and it should be a pretty much seamless transition. You can kind of see the flicker on the camera, but in person, I can't really see that flicker happening. Just the camera's got a high enough refresh rate, so it kind of catches it here and there. But with a higher quality camera than my little hovercam classroom camera, you could definitely see it flickering back and forth if you were to slow the frame rate down. Okay, so how this multiplexing works is it's quite a bit of a complex setup, but we'll go through it, and I think you'll be familiar with some of the tools already. Okay, so here I've just created an array with each of the numbers already programmed in. So this is 0 and 1, etc., etc. And so all I'm doing down in my loop is just referring to that array and pulling out the appropriate number based on the counter value. Okay. So back it up here. I've got my constants. So these are never changing. And then I've got my regular variables. And these are going to change throughout my program. So the first one is my multiplexing flipper. So this one is just a Boolean variable. And it's just going to flip between true and false every single loop iteration in the Arduino program. Okay, next up, I've got my counter, and this one just keeps track of what number the counter is currently on. So right now we're at 0, 1, 2, 3. That was good timing. And then I've got an interval, in this case, 1,000 milliseconds. Okay, so if I wanted to go double the rate, I could cut it down to 500, and then I would just flip through the counter every 500 milliseconds. Okay, unsigned long start time. This is used to track the current start value. So this is kind of the same technique we used for or earlier to keep track of what number we're showing here. Okay, and so this one, instead of creating a while loop that holds, we're going to continue our program rather than using a delay. It's going to allow the program to continue iterating through while we can check how many milliseconds have passed since the last time this loop ran. Okay, setup, same thing as before. I've just got a 1s and 10s anode now. So I've got this is going to control how our multiplexing is showing up. If my 1s anode is set to high, then this SSD on the right is powered. If the 10s is high, then it's going to power up the SSD on the left. Okay. Down into the loop, I've got if mux. So this one, all I'm going to do is check to see, first of all, if it's true. I'm going to turn on the 1s SSD. If not, I'm going to turn the 10s off. So that would be like showing this. Okay, so just going to turn this one on. Kind of see the flicker there. And it's going to turn the 10s off. Okay, so every iteration where mux is true, it's going to only write to the 1s. Okay, so to get this number, I've got counter modulus 10. And what this does is returns the remainder of a division by 10. So for example, if my current counter value is 23, it's going to return the 3. Okay, I'm going to zip back up to nums. It's going to pull out the value of 3 and print that to my port. Okay, so it's going to print out that specific sequence of values for port D, which is then just going to power or depower the SSD segments. Okay, then mux is flipped, and in this case we're going to do the 10 side, and all I'm going to do here is an integer division. So it's going to do counter divided by 10. So let's say it's 23 again. It's only going to return the 2. Okay, it's going to truncate or cut off the rest of the number. So the actual value 23 divided by 10 is 2.3. So it's just going to return the 2. Okay, and then it's going to print out 2 in this case from that nums array up top. Okay, so port D is going to be assigned, and then we just continue on. It's going to sit there for a quick 10 milliseconds. If we reduce this, actually I'll go back to that in a second. So here I'm just flipping mux back and forth, and this section is to reset actually this one is to check if a second has passed. Okay, and here reset the clock or reset the counter to 0. Yep. If we don't do this, we're going to get some crazy numbers happening on this display. So we have to reset it to the maximum value that it can be, which is 99. Okay. So it reaches 100, which is going to reset counter to 0. Okay. Start time set to millis, so it's going to restart counting for those milliseconds, and it's going to continue displaying the same values until my interval is reached, or millis minus start time is greater than interval. Okay. Once that happens, it's going to continue the cycle, iterate counter again, and then check to see if it's over or reached 100 yet. Okay, so back to my delay. So this is kind of where the magic happens. This one, if I take delay down to 1 and go through my upload process, hopefully, there we go. Okay, so now, if I plug these back in, okay, it's actually not too bad. You can kind of see it on in person. I can see it, but in this, there we go. Now you can really see it. So what happens is it's actually ghosting. The process is happening too quickly to allow time for these segments to actually depower. So what we have to do is give the Arduino time to flip back and forth, let the circuit completely drain and depower. Otherwise, we get that kind of digit ghosting in the background. So you have to kind of watch for the that happy medium between the two. So if it's too short, we get ghosting, and if it's too long, we end up getting the flickering in the camera or in our eyes. Kind of an interesting experiment. If you kind of look out of the corner of your eye at the displays, you can actually see them flickering back and forth. you'll probably kind of see this out and about when you see like electronic screens, etc., or if you're playing a video game and your monitor has a slower refresh rate, and you can kind of see that that flickering out of the corner of your eye. It's just because your peripheral vision is much better at picking up that fast rate. Okay, so that's multiplexing in a nutshell. Okay, I'll post this code up for you to try things out. So in terms of wiring, the only major changes you have to do is move the your anodes to a specific ports. I think I did ports 11 and 12, and just random jumper so I could easily unplug them and plug them back in for uploading. And then next, I've got some blue wires here, so I just ran them from my ones digit to my tens digit to complete the circuit for my tens digit. Okay, so don't worry about the button yet. That'll be for the next lesson. But anyways, okay, good luck getting that wired up, and see what you can do.